Okay, so here we're going to be looking at firstly the key outcomes with this particular chapter, which is functions in relationships, right? So now the first thing is that you need to be able to determine the input values, output values, or rules for the patterns, right? And relationships using either a flow diagrams, tables, or formulae or equations, right? And then also, you need to be able to determine and interpret and justify equivalence of different descriptions, right, of the same relationship. So in this case, they're just talking about if they had to put it in a flow diagram, you are able to convert some of the information that is there into maybe a formula or into a table or into equations. And all the rule presented verbally in formula um, in tables or by formula or by equations, right? So the introduction here is that a functional relationship shows the connection between a set of input values and a set of output values. Now this is quite important for you to know the difference between an input and an output value. Now the first thing that I would say about an input and output value is that the input value is the value that you put into the function, and then the formula changes that particular value into an output value. What does that mean? It means that in actual fact the output value is actually dependent. It depends on the input value. So whatever the input value is, for a single output value, you will always find a single input value that is specifically made for it. There are cases where, for instance, if you have a formula or an equation that says x to the power 2, right? You could put in positive 2 in there and you'd find that the answer would be 4, right? So the input value would be 2 and then the output value would be 4. But then you do find in cases where you'd have negative 2 and you'd put it into x to the power 2 and you'd find that it gives you actually just 4 again. So there are cases where you find that, but generally it should be one input to one output. Okay, and then so we basically call the input values variables and the output values as variables as well. Because why we call them variables? If you think back to when you looked at algebra, when you talked about a variable, you'd say that it is any possible number that can be placed in the place of that particular letter, right? And when I say that particular letter, in this case, we generally like to use, for input values, we like to use x, and for output values, we'd like to use y. Not always. There are cases where you'd use different letters, but it would still be an input value for the simple reason that it is a number that you're putting into the equation and then you're getting out something, right? And that number that you're putting into the equation could be any possible number that you can think of. So in mathematics, we refer to the relationship between the corresponding values of such related variables as a function, right? And as I stated, is that the input variable is independent. It's an independent variable, meaning that it depends on nothing. Because as I just said, if you're going to be putting into, if you're going to be putting an input variable, right? You could choose any possible number. It means that if you're choosing any possible number, it doesn't depend on anything, right? It doesn't depend on anything at all, right? But when we're talking about the output variable, right, which is it's a dependent variable, it's also known as a dependent variable. That basically means that in actual fact that particular number that comes out depends on the input variable, right? And we usually use x and y to donate these particular input variable and output variable, right? So you can read the rest on your own. You just have to stop the video and read it. So here we have a flow diagrams and a table representation. So here's an example of a flow diagram, and I think you've seen this quite a lot in your previous grades. So here you have in the center here you have times 2 and then you have plus 1. So what actually happens here is that we would say it's 1 times 2, that gives us 2, but then 2 plus 1 gives us 3, right? So that would be a flow diagram of the function, right? So if you notice, if we would say 1 times 2, that plus 1, right? And x times 2 and plus 1 come from the flow diagram over there, you'd see that it gives us 3, and so on and so forth. But as you can see here, I've written out 1, 2, 3, 4, and 5 as in red, right? Why? Because it is an input value, because you can place anything into it and it would go into the flow diagram, and then it will be multiplied by 2, and then added by 1 to give us an output value, and the output value is in black, meaning that it is the dependent variable to the input variables, right? So in green is the function rule, right? The green part is the function rule, meaning that we have an input and we're multiplying it by 2, and then we add it by 1, right? So any possible input, we multiply it by 2 and we add it by 1, and that gives us an output. But usually, as I had stated above, that we like to donate it with X or Y, right? So the input, we like to donate it with X and the output with Y. So if we had to replace the input, this part here where we say input with X, then it would be X times 2 plus 1 is equals to Y, which is the output. But this is the same as writing it as Y is equals to 2X plus 1. So you must notice that. And remember, this idea that, okay, we have 2X times 2 to be the same as 2X is that, remember, in algebra, you don't necessarily have to write the multiplication sign in between a number and its variable when they are multiplying each other, right? And that's why we can say that it's just 2x, and that's why it is the same representation. It represents the same thing. This y is equals to 2x plus 1 is the same as saying representing it here as a flow diagram. Okay, so here's another example here. So they would ask us, they say, copy the following table and use it to show which output numbers are connected to which input numbers in the above flow diagram, right? So now you have here, you have 10, 20, 30, 40, 50. These are input variables, input values that have been chosen, right? That have been chosen, right? And meaning that it could have been anything else, but they chose 10, 20, 30, 40, and 50. So what happens is that it says 10 times 4 minus 15, and we know that 10 times 4 minus 15 actually gives us 25. 20 times 4 minus 15 gives us 65, and so on, right? And then you have 30, 40, and 50. So your input values, or the input values, should always be actually on the flow diagram on the left hand side, right? And then your output values should always be on your right hand side. Okay, and so your input is multiplied by 4 minus 15 to give you the output. And remember, the output depends on the input. So whatever is placed as an input will have a unique output, right? So then the formula that we would write it out as, we'd say it's 4x minus 15 is equals to y, right? Or you could write it as y is equals to 4x minus 15. Okay, so yeah, so the important thing, something that you need to remember that is very important, is that a quantity that changes, right? A quantity that changes is called a variable quantity, or just a variable, right? And that's the whole point, and that's why we call this an input variable, because it does change and we could place any possible number. But also the output value, it does change depending on the input value, right? Okay, then we have an example of the table representation. So in this case, they would say maybe find the missing m values of the function n is equals to m plus 3. And as I had said, it doesn't necessarily mean that they'll always use x and y to signify the input and the output. In this case, they used n and m. So in this case, how do we find our m? So as you can see, here you have n, which is equal to 5, but this n, remember, it's the output, so therefore this would be 5 there, so you say 5 is equal to m plus 3, and then you just use your techniques or the tricks that you've learned on how to solve, right? And whatever you do on the left hand side, you must do on the right hand side. Therefore you'd say it's m plus 3 minus 3, but because you are subtracting 3 on one side, you must subtract 3 on the other side, so it's also 5 minus 3, and then you'd actually get that 5 minus 3 is equals to 2, therefore your m is equal to 2. And then you can see for the rest you do the same in for 0 and negative 4. Okay, and so remember the question, it also says represent this function in a flow diagram. So how can we represent this in a flow diagram? So in actual fact, if you think of it, it's actually 2 plus 3 that gives us 5, and minus 3 plus 3 gives us 0, but minus 7 plus 3 does give us minus 4. And you can see on the left hand side you have your inputs, and your right hand side you have your outputs. Okay, and so I would like for you to try out this particular question. So as I said, please try this out on your own. So you just stop the video and try it out, and yeah, if you have any problems, please ask the person who's helping you, or if not, you can send the question through to us. And so it is important to remember what are the important things to remember here. A relationship between two quantities can be described in different ways, including a table values, right? A flow diagram, and a word formula, and a symbolic formula. And we have seen actually the table representation, which is this one here, and also the flow diagram, which is this, and also the formula representation, which we've seen over there as well. These are all different ways that we can represent them, but now you need to be able to also explain them using words. So for instance, here's an example where it says describe each of the functions below in words. So what I've done is the ones that I've highlighted in red are the ones that I'd like for you to try out on your own, but the one that is not highlighted is the one that I'll talk about. So for 1a, right, it says y is equal to 2x, right? So if it's y is equal to 2x, what does that mean? It means that the input value is multiplied by 2 to give an output value, right? And so that would be how you can describe it. But not only that, when you look at number 2, it says complete a flow diagram for each of the functions below. It says y is equal to negative 3x, right? So if it's y is equal to negative 3x, what does it mean? It means that if we had to make a flow diagram, then we choose any possible inputs, right? We can choose any possible inputs. And these possible inputs that I chose is negative 1, 0, and 1. You could have chose any other number yourself. But when we say it's negative 1 times a negative 3, right? And I said negative 3x to signify that we are taking into account the formula that they did give us. And we do know that the inputs are x, right? So it's negative 1 times negative 3, and that gives us 3. If it's 0 times negative 3, it's 0, and if it's 1 times negative 3, it's negative 3. And so the last question here, they wanted us to find the equation. Now, the first thing that you need to have noticed here is that it says hours is negative 2, 0, 2, and 4, and then income it's 10, 0, negative 10, negative 20. But now, what do you notice here is that if we say 2 times negative 5, it does give us negative 10, because negative 2 times negative 5, it's two negative numbers, therefore it will give us a positive number, but 2 times 5 does give us 10, so therefore it should be just 10. And if it's negative 5 times 0, it does give us 0. If it's negative 5 times 2, that just does give us negative 10. If it's negative 5 times 4, it does give us negative 20. And so you can see that this works, right? And the last particular exercise that I would like us to see is that if they've given you something like this and they would say, find the values, right? So what would you do in this case? So you check by taking the input value and seeing whether or not one of these equations for all of the input values, would it give you the same? So the first one that you can see here is that in actual fact, I have 1 as the input and 7 as the output, 4, 22, 11, 57, 30, 152, 40, 220, 202, and 60 as 302, right? So if I take E, which is 5x plus 2, what do you notice is that in actual fact, when we say 5 times 1, that gives us 5, plus 2, that gives us 7, and so on and so forth, right? And so that's how you check these ones, right? And I've given out the first 3, and I'll leave the last 3 for you. So other than that, I really hope that this video is helpful, and the questions that I have not done, I'd like for you to try it on your own. If you need help, please ask the person that's helping you. If not, if you'd want to send through the question to us, feel free to send the question through us to us, and we will be able to assist you. Other than that, I wish you all the very best. See you next time.